Okay, so now we wanted to talk about chapter 9, matrices and determinants. First, we wanted to talk about the matrix solutions to the linear systems. Okay, so the objective of this section will be first write an augmented matrix for a linear system and perform the matrix rule operations, only rule operations. Use matrices and Gaussian elimination to solve the system, and use matrices and Gauss-Jordan elimination to solve the system. So we have two kinds of elimination method: is Gaussian elimination and Gauss-Jordan elimination. Okay. So what is a matrix? So a matrix will be look like 1, 2, 3, 4. Yeah. So and you use a matrix symbol to rewrite it. It's in a rectangular array here, okay? And you have rows and you also have what? Columns. Okay? So augmented matrix. What is augmented matrix? Okay, so the augmented matrix has the vertical bar separating the columns of matrix into two groups. The coefficient of each variable are placed to the left of the vertical line, and the constants are placed to the right. Okay, so what does this mean? So if you have a system of linear equations like this, yeah, so the matrix of the coefficient will be what? Will be on the left. It will be what? 3, 1, 2, 1, 1, 2, 1, 3, 2. Yeah. So this is the matrix of the coefficient, and the augmented matrix will be what? You have a vertical line that separates the coefficient, and put all the constant on the right side. So this will be called what? Augmented matrix. The augmented matrix. This is the matrix of all the coefficients. Okay, all the coefficients. So we will say this one is coefficient matrix. Okay, and similarly, when you have 1 to -5, when you do not have x term here, what happens? It means the coefficient of x is what? 0. And similarly, if you do not have x and y term, you have 0, 0 here, yeah? Okay. Okay, and this one, later on, actually, this one is called what? Diagonal matrix, upper diagonal matrix, okay? Okay, and, okay, so a matrix with ones on the main diagonal and zeros below and ones to set to be what? Row echelon form. The row echelon form. Okay, so we have in this book we call it what? Row echelon form. So we wanted for the row echelon form, and we can use row operations to on the augmented matrix to produce a matrix in a row echelon form. Why do we wanted this form? Let's look at here. So the idea is to what? Solve the linear system, yeah? So if you are in the row echelon form, you know z equal to 4. How could you find the solution? You have x, y, j, yeah? So what do we know? J equal to 4. How could you find y and x? Okay, so you substitute j equal to 4 in what? Y plus 3j equal to what? 9. What will you get? Y plus 12 equal to 9. Y equal to what? -3. And then what will you do? You substitute all the y and j's into the first one. You have x plus 2, -3, minus 5, 4, equal to -19. So x minus what? 26 equal to -19. So x equal to what? 7. So what happens? So if you have the row echelon form, it's very easy to solve this question, yeah. So because what happened, and you can find j, y, x very easily, very easily, yeah. So this is why they wanted you to have the low echelon form, okay. Okay, good. So now how could we get the low echelon form? Okay, so we wanted to introduce what the matrix row operations. What does this mean? So we can do these row operations and your solution set stay the same. So because you do not want to do any row operations, then your solution is changed, and that's not good, yeah. So what could you do? Okay, so these are the words as a mathematician, that's too much. Okay, so what will be the simplified version? Okay, so it will be these things. Okay, so if you have a row equivalent, okay, you can do these steps. Interchange the element in the i's and j's rows. You can I and ij, you can interchange. And you can multiply each element in the i's root by number k. And you can add the k times element in the row I to the corresponding elements in row J. Okay, so what could you have? It's KRI plus RJ. That's okay too. Okay, so what these three steps will help you to do is to get you the low echelon form. Okay, you want to do all these all these operations on the matrix is to get you the low echelon form. Okay, so then let's look at the example. Okay, so what could you do? You can do the row. You can interchange two rows. Yeah, so it will be stay the same. What happens here? So if you have this is the first row and the second row, you can interchange. When you interchange, do not forget to interchange these two numbers too. Yeah, so it's the whole row here. Otherwise, something may get wrong. Okay, so the next example, you can also perform, you can also multiply something or divide a constant. Yeah, so for here, if you multiply 1/4, you multiply 1/4 on every element on the first row. So you have what? 1, 3, -5, and 2. Okay. And the third one is, okay, so what could we do? We can 3 times R2 plus R3. Yeah, so this is R1, R2, R3, row 1, row 2, row 3. Yeah. So what did we do? We can multiply 3. So you 3 times 1, 3 times 6, 3 times -3, 3 times 7. Yeah, you add them to add on the R3. So you get this. Okay, so these are row equivalent. Okay, so these two matrices are row equivalent. So you will have the same solution. You can do these three operations. Okay, so this is a very good summary here. Yeah, so if you wanted to solve a linear system using Gaussian elimination, what are the steps? Okay, so first step is you wanted your first row to be the first number on the first row to be what? 1. Yeah. Okay, so why? Because you wanted what? On the diagonal to be 1, 1, 1, and all below the diagonal is everything is 0. Yeah. Okay, so the first thing you can get 1. You can either interchange the row, you can either interchange the two rows to make it the first equal to 1, or you can multiply some number to get the first row to be the 1. Okay, After you get the first one to be 1, what could you do? You wanted to get the others to be 0. What will you do to get the others to be 0? Like for this example, when you have 1 here, how could you make this row to become 0? You multiply, if this is negative 3, you multiply 3 here, yeah? So then you add them together, it will become 0, 0. Are you with me? So you get these two things to be what? 0. And then what will you do? You repeat, yeah? So for your second row, you can multiply some scalar to make the middle number to be 1. And then you will repeat the same thing here again. So you multiply the second row by a scalar to make this number to become 0. And then finally, what will you do? You repeat the first step, make this number to be 1 by multiplying a scalar. Okay, so this is the process. Okay. Okay, so this is this one, yeah. Okay, so what should we do if we have augmented matrix like this one? Yeah, so what should we do? Yeah, so we wanted the first one to be 1. What could you do? You can either change the first one with what? The second one, or the first one with the third one. Yeah, it does not matter. Yeah? So what will you do? Maybe you R1 exchange with your what? R2. What do you get? 1, negative 1, 2, 9, 2, 1, 2, 18. Yeah. 1, 2, negative 1, 6. Yeah. So then what should we do to make a 0 here and a 0 here? So what will you do? So in order to make it add equal 0, so your R1, you have to times what? Negative 2, you plus what? R2. In order to make this one 0, so what will you do? R1 times negative 1 plus what? R3. Okay, so in order to save some space, I will do it together. So R1 negative 2, what do we have? So negative 2 positive, so R1 you stay the same, yeah? 1, negative 1, 2, and 9, yeah? 1 times negative 2 is what? Negative 2, so become 0. Negative 1 times negative 2 is 2. 2 plus 1 is what? 3. So 2 times what? Negative 2 is negative 4. Plus 2 is what? Negative 2. So 9 times negative 2 is negative 18. Plus 18 is 0. It's good. Okay, so what should we do for the next one then? 1, negative 1, yeah? So what will you do? 1, negative 1 here. So what do you get? So here is 0. 1 times negative 1. Negative 1 times negative 1 is 1. So you have what? 3. And 2 times negative 1, what do you have? Negative 2. Negative 2 plus negative 1 is what? Negative 3. So 9, negative 1, and you have what? Negative 3. Are you with me? Okay, so good. Okay, so what should we do from here then? Yeah, so what do you notice? What do you notice? You could change what? You wanted to make a 1, yeah? So what will you do? You multiply 1/3, yeah, with what? R3. Yeah, so 1, negative 1, 2, 9, so 0, 3, negative 2, 0, 0, 1, negative 1, negative 1, yeah? Are you with me? Because here I do not want this because I do not want a fraction. But what could I do? What could I do? So what I need is a black page, yeah? Okay, so what will I do? So I will exchange R2 with what? R3 again, yeah? So what do we have? 1, negative 1, 2, 9. Yeah. Okay, so what do we have here? 0, 1, negative 1, negative 1, 0, 3, negative 2, 0. You with me? So now we have a 1 here. Then how could you get rid of this 3? So your R2 times negative 3 plus R3 again. Okay, so what will you get? What will you get? 1, negative 1, 2, 9. Yeah, so you keep the same. So here you have time negative 3. What do we have? So this part goes to 0. Negative 1 times negative 3 is 5. Negative 1 times negative 3 is 3. 3 plus 2 is... Oh, okay, so I will keep the second row the same. So 3 plus... So here is 0. Here is 0. This one is what? 3 minus 2 is what? 1. Oh, that's really good. Eh? So then negative 1 also times negative 3. So negative is positive 3 plus this 0. So it's become 3. Okay? Do you have the echelon low echelon form? Yes, we do. So what does this mean? This means what? Your G equal to what? 3. Oh no, I will write it, in the order. So first thing you have x minus y plus 2g equal to 9. What do you have? Y minus g equal to negative 1 and g equal to 3. Yeah. So how could you solve this? You back substitute, yeah. So y minus 3 equal to negative 1, y equal to 3 equal to 2. Then so x minus 2 plus 2 times 3 equal to 9. Minus 2 plus 6 equal to 9. Plus 4, so x equal to 5. What do you have here? It's 5, 2, 3 is your what? Final answer. Okay, so let's compare with the book. 5, 2, 3. You with me? Okay, so you can, if you wanted to find all the details with the explanations, you can, follow the steps on the book, or you can, look at mine, and it's all together without, so many words, and it might be easier. Okay, so this is this example. Okay, so the next one we wanted to talk about is solve the linear system using what? Gauss-Jordan elimination. Okay, so what means the Gauss-Jordan elimination? So first you write the augmented matrix for the system, and then you use what? Row operations to simplify the matrix to a row equivalent matrix in the reduced row echelon form. Okay, so you get 1 on the first left corner. Okay, use all these things. Third column, use the 1 to main. And then you reduce the row echelon form of the matrix in step 2 to find the system solution set. Okay, you have all these steps. Okay, all these steps. Okay, so what will be the difference? What will be the difference for the Gaussian elimination and the Gauss-Jordan elimination? So look at the final answer. For the final matrix, what do we used to want? We only want what? Zeros on the bottom. Now what do we want? We want zeros on the top too. Okay, so the idea to do this, yeah, so you can get it, follow the steps for the row echelon form to get all zeros. It's exactly the same. Then what do you want it to do? you wanted to get all these things to be 0, yeah? Okay, so I will, my method is what? To backward. Okay, you always go backward. Okay, so what will you do? You go backward. Okay, so how could you make the second row to be 0? I will do what? R3 plus what? R2. So because all of these are zeros, so it will not affect here, yeah? So what will you do? You keep your R3 to be the same, 0, 0, 1 to be 3. So you make this one to be 0, you add them together, yeah? So you have 0, 1. So 0 plus 1 is still 0, so it does not matter. 1 plus negative 1 is what? 0. 3 plus negative 1, what do you get? 2. Are you with me? 1, negative 1, 2, and 9. Are you okay? Yeah? Okay, so I think I will insert another blank page, yeah? So what will we have? So now you get the third row and the second row as what you want, yeah? Okay, so 1, negative 1, 2, 9, 0, 1, 0, 0, 0, 1, okay, 3, 2. Okay, so what do we want it here? So how could you make this to be 0? The second row, so R2 plus R1. That will make it 0, yeah? So it's 0, 1, 0, 0, 0, 1, yeah? 2, 3. So R2 and R1, what will you get? So because could we do this? Because your R2 is perfect too, yeah? So then you have 1, 0, 2. So because 0 plus 2 is still 2. 2 plus 9 is what? 11. With me? Okay, so now the only number that is still trouble is the 2 here, yeah? How could you get rid of this 2? Your 1 here and your R3 has 2 times what? Negative 2, because this is 1. You wanted a negative to add together, yeah? Times negative 2, then you plus what? R1. Yeah, so because all the other numbers, all the other coefficient is what? Still 0. So 1, 0, 0, 0, 1, 0, 0, 0, 1. So you have 3, 2. The third one does not matter. So 1 times negative 2 plus 2 is 0. 3 plus times negative 2 is what? Negative 6 plus 11 is what? 5. Okay, so and for this one, yeah, so the benefits here is once you do all these continuous rule reductions, it's called Gauss-Jordan for elimination. You do not even need to solve the three variable linear system anymore. You can directly write the solution, because here is what? X equal to 5, y equal to 2, j equal to 3, because you do not have yj here. So only x equal to 5, only y equal to 2, only j equal to 3. Okay, so this is the Gauss-Jordan elimination. Okay, so you can use either method. If you are pretty, happy with the matrix elimination, use Gauss-Jordan. And if you wanted to say, oh, I do not mind, try some, solving some linear systems by hand, then by hand. Okay, so these are the examples. And this is